Continuing on to section 4 of chapter 9, properties of logarithmic functions. And we'll be doing products, powers, quotient, and then tying them together. Now, they do give us this interactive discovery, and we're to use a calculator to determine some background in this, but we'll pass that up. And let's get on to our first property, and that is logarithms of products. Now, keep in mind, we're dealing with exponents as we talk of logarithms. And if we had a to the m times a to the n, in which our bases are the same, the results of this is we just add our exponents. So it becomes m plus n. And the proof of this will be in example 2 that we'll see here shortly. So, keeping in mind that when we have log of, let's say, base 2, and it equals 8, or we would read this log base 2 of 8 is going to be 3. That is, what exponent will raise this base to this answer? And it would be 3, because this would be written then 2. Now we take the exponent to the third, and that equals 8. So we've seen this throughout chapter 9 here as we look at exponents, but it's always good to have a little review. So when we see something like this, we could rewrite this, because in a sense this is multiplication between these two. We can rewrite that as log of base A of m plus log of base A of n. So if you're just not familiar with what they're writing here, again, take notes and work it out. All right, let's go on and see an example. I won't raise it, so we'll keep all of this there. Now, express an equivalent. Here they're just asking you to write it in an equivalent way. That is a sum of logarithms. So we have log of 2, and then it's 4 times 16. Well, we could rewrite that as log of base 2 of 4 plus now log of base 2 of 16. And that's what they're showing us here. Now, in just a moment, we're going to work this out. And I see things are loading on my computer here too, but we'll move on. So, let's take a look at what they have over here. Here is log of base 2 of 4 times 16. Well, this would in a sense be log of base 2 of 64, right? Would you all go along with that? Okay. Now, if we separated this into what we're saying is okay to do, that we put a plus here, what does this become when we put it in our exponential form? Well, base 2 to what exponent is it 4? And we know this exponent here is going to be 2. 2 to the second equals 4. All right, how about this one? Log of base 2 of 16. Well, there's our base 2. We don't know the exponent at this time, but it's going to equal 16. Well, 2 to the 4th power is 16. Now, when we are doing this and looking at the previous slide or keeping it in mind, how do we do this? We go 2 to the second times 2 to the 4th would be equal to what? 2 to the 6th. And what is 2 to the 6th? 64. So there you see, again, we're just showing you how to interact with logs and exponents, and then being able to simplify it or express it in these terms that we're doing down here. Okay? So let's look at example 2 then. Express as an equivalent expression that is a single logarithm this. So here we have log of base b, and here we have a 7. Again, my computer's updating. A 7 plus the log b of 5, and from this, up over here, we know we can just multiply the 7 and the 5 and get 35. We have made an equivalent expression that is a single logarithm. So we had this, and again, you're looking for strategy here. If you just multiply these, you get your answer. All right, let's move it up. Now, this is the proof of the product rule, but I just did it up to the left in the previous slide. But you can look this over some more if you'd like. Okay, let's see what they say. Find your pace. I like these. When new material seems challenging to you, do not focus on how quickly or how slowly you absorb the concepts. We each move at our own speed when it comes to digesting new material. Now, I've been working on chapter 9 over the Christmas break here, the winter break, and trying to do like one section a day. Then New Year's crops in and I have to take a little more time. So I'm doing this too, and I'm treating it as if I were a student myself looking at this material for the first time. In some cases, it is the first time for me. So hopefully, again, we're giving you strategies to look at these things and little by little. Okay, logarithms of powers. Now, again, when we look at this, what are we talking about? Well, if we have a to the m power raised to the nth power, we know that in this case, we don't add, we multiply. So this would become a to the m times n, which is what they are illustrating there. So how do we see this then when we look at logs? Well, it's going to be log of base A of m to the p power. Now, you take this exponent here and we put it in the front of the log of m. So this is what is equivalent. Now, let me write that out here. So if you had log of a to the m to the p power, that will be equivalent to this p coming out in front as times the log base a of m. Now, again, as you are looking at this, reading it yourself, studying it, you want, and taking notes, we're assuming, so you have a reference of what this is all about. And then through repetition, working the examples, working the practice, doing the quiz-mes, you'll start to remember this and develop mastery. That's what we're looking for. All right, to better understand the power rule, note that here we have this. What does that mean? Well, it's this m is used 3 times. So that's where that 3 out in front comes from. So it could be written this way as well. And some of this will be used in your, later the booklet, the additional examples, and of course in your practice and quiz-mes. All right, so let's work on example 3. We're going to use the power rule for logarithms to write an equivalent expression that is a product of this and this. So I have it written up over here, and let's look at what we're going to do. Well, we're going to take this exponent, put that out over here, -5, and then write log our base a to the 9th. So again, all we had to do is take this exponent and put it out here that we're going to multiply. Now how about this one? Well, this one, even before we change it, what do we know about this from chapter 7? Well, that is log of base 7, log base 7 of this. And another way to write this would be x to the 1/3 power. Does that make sense? The third root of something is x to the 1/3 power. So this then becomes, we're taking our exponent, putting it out in front, 1/3, and then log of base 7 of x. And again, you'll be practicing this and then doing your quiz-me on it. Now the proof of this, again, is what I worked out in the last slide. That is a to the x raised to the p power is equal to the product. Okay, you multiply exponents. So you get a to the xp. Now they're multiplying here where m is the result of that. That multiplication, that's what the m is. Okay, so let's do logarithms of quotients now. Now, again, reviewing back to where we had this, if we had a to the m divided by a to the n, the way we did that, this crossed, and the bases had to be the same to do this, this exponent crosses the division bar and it changes its sign. So we get subtraction. That's what they're showing us here. And we'll have the proof in chapter 5. So the quotient rule for logarithms for any positive number m, remember m is the of m, and n and a do not equal 1, we can then work this out, and let me write it over here too, that we know that this is what this is up here. So we are going to subtract then, and this will become log of base a to the m. That's our product. And to indicate our subtraction, we then say minus log of base a, log base a of n, which is what they have here. So again, you want to think of a way you could tie these together. This process of subtracting exponents right here is illustrated then in logarithmic expressions as this. And again, you need to write that down. I wouldn't remember it in one showing, and I'm assuming many of you may not either. Okay? So let's take a look at this example down here. Taking this in pieces, let's do this first one first here. We have log base 2 of 8 over 32. Well, I can simplify this fraction to 1/4. So these are equivalent statements. Now I want to put this into an exponential form. My base is 2. I'm looking for an exponent up here that will equal this of 1/4. So what exponent back from section 1 do I put here? Think about it for a moment. And it's a -2. And that's what they're showing right here. Now I got the -2 again from thinking, what exponent does this equal down here? Well, it equals, again, putting it into this form to figure out what exponent goes there. And it's -2. Okay? Now, notice if you did it the other way. You went log of 8, well, log base 2 of 8 minus, as we were showing you over here, log base 2 of 32. Now, what is this one? And let's do that as well. We'll focus down here. So, again, we're doing this line right there. And we've converted now log base 2 of 8. What is our exponent? Well, we're going to have 2 to the 3rd power equals 8. And then minus base 2 log of what to give you 32? Well, this happens to be 5. Now, 3 minus 5 is a -2. which is what they have right there. Now again, your textbook is showing you things, and sometimes they give you lots of information. And then sometimes, maybe this extra information that I'm adding from previous lessons that they're hoping you already know is going to be useful. Okay, let's go on. As we go on to example 4, express as an equivalent expression that is a difference of logarithms this. Well, first of all, I don't like it written this way, but they do correct it down here. So all of this would be is to do the log base t of 6 minus, because it's division, log of base t to u. So this is just the equivalent expression of this, showing you what we're doing. Example 7. Express as an equivalent expression that is a single logarithm that this minus this. Well, it's just the opposite of this. So what you're going to do is take log of base b, that's this one, and since this is subtraction, we're going to put the 17 over the 27. And that's all we have to do. Okay? It's nice to get some easy things. You need to know the protocol, the strategy, the modus operandi to get this done. And again, as you write your examples in your notes, you are developing a model by which to do other problems that are set up in a similar way. Let's go on. Now we showed you already using other slides the proof of the quotient rule. Now it's a little tricky when you get some negative exponents, but all it means is that that is in the denominator. Okay? Instead of being a positive one, it's in the denominator. As you see here, rewriting m over n can be written this way. Okay, let's go on to use some of these properties together now as we, in example 6, express as an equivalent expression using the individual logarithms of x, y, and z. Now, they have it all written out here, but maybe what I'll do is write it out over here. I think is helpful. So what do we have here? Well, we want to write this as an equivalent logarithmic expression built on what we've learned so far. So we have this exponent 3 here. So I'm going to put my 3 out here, this 3 out here, log of base b of x. So this first part is this right here. Now what I have to do is subtract this. So I'm going to subtract now log of base b y. Now I'm going to subtract this one also, minus log of base b c. And I believe that's what they have right there too. Okay. And again, they're showing you the rules. Now, if there were exponents on these, they're not. There's just a 1 there. So in a sense, there's a 1 there and a 1 there. If there were a 2, we'd have a 2 there. If there was a third power, we'd have a 3 there. Okay, and I'm going to do B now as well. Now, this is our original example. A key to help start to work it, I think, is important, and they show that here as well, is we convert the radical into fractional exponents. So 4th root would be our denominator 4, and this is all to the first. So our numerator is 1. So I've just recopied this into this form. So this is the exponent, okay? And if I do this live, it may be a little easier to follow. So this is our power to a power. So I'm going to put the 1/4 right out there, and then I'm going to use parentheses to indicate this 1/4 applies to everything in the parentheses. So now I'm going to do it. Log of A to the x, that's this one, plus log of A to the y, that's this one. And then I'm going to do minus, because I'm in the denominator, but what is that power to? Well, it's 3 log base A and then to z. So where it may look daunting down here, and we don't get to see the whole thing, well, I guess we do here a little bit. Taking it apart doesn't look quite so bad. Let's go on. Now we do want to look at the whole thing, and there it is right down there. Okay? Now they had an intermediate step in here too, which is good. You wrote it out already. Okay, now looking at example 7, we're going to take what we had in its long form and then revert it to its short form. So in letter A, it's going to become this. Okay? And it's actually too much writing. Let's see if we can just follow it now. So we know this is 1/2. This is going to be a radical, the square root. Okay? So we have log A. We know this is going to be, because of 1/2, will be the square root of x. Remember, there's a 2 there and a 1 there. When we convert that to its fractional form, that's where we get the 1/2. Okay? Now, we then have a negative 7, the log of base A to the y. So we know that this is going to be in the denominator because it's negative, and it tells you that that y is to the 7th power in the denominator. And then we still have this. Now, plus log base A z. Now we could put that z afterwards, but most commonly it's placed in the front. And there's letter A. Let's go on to do B. We'll take this one in pieces. Here is our original example, which is right here. Now, to combine this, and keep in mind this is positive, so this will be on the top, and it's just the product of this and this, which is what I've done here. And this remains on the bottom. So our next step then is, now if we take this, just this part here, and put it under a common radical, we have this. Notice what happens. Our x's will cancel out here. And we're just left, here the x's will cancel out. We're just left with that under the radical. Now, as we convert this, remember this is to the first power. This is b to the 1/2 power. So in a sense, this is b of 2 over 2. We're going to add our exponents there, so we get the log of a, b to the 3/2. 2 over 2, that's 1. That's what we have here, a 1. This is to the 1/2 power. See, they're not showing you that quite there. In a way, well, over here, yes, a little. And now we get this. So how do we write this in our final form? Well, we take this exponent, put it out here as 3/2 log base A of B. And that's what we have here. Now, in a sense, you could write it either way. You could write it this way or this way. Again, they do get a little challenging, but again, writing it out, I've said it. So you need to work on your strategy so you can gain mastery. So as we look at example 8, here they're giving us this, and they're giving us this. So log base 2 of, base A of 2 is this. This is the exponent. And log base A of 3 is this. This is the exponent. So they're asking us to calculate values for these. So for letter A, we have log A of 6. So as we think of 6, that is actually 3 times 2, or 2 times 3. So we can rewrite that as the log A of 2 plus log A of 3, which is then just taking these values for the 2 and the 3, adding them together, and our answer for A then is this. And the check is that actually we said that A to the this power is the sum of these, which was a 2 and a 2 times 3, which is a 6. Okay, that was a little challenging. Let's put a line here, and now we'll work on letter B. And to use some of the book's work here as well, here we have B is this, which we know we can write in this form, where 2 is our numerator, 3 is our denominator. We're going to subtract. So we're just going to subtract these values, and we get this as an answer. All right, let's look at C. So for letter C, we saw we had an 81, and we wonder, how does the 81 reflect to 2 or 3 up here? And the answer was we had to convert that 81 to 3 to the 4th power, which is 81. And we write that by putting the exponent out in front of the log, base A of 3. So now that we know what we're doing, we do have a value for 3 up here, which is this, that we're now going to multiply it by the 4, and then we get a value. All right, letter D. So we have the log of base A to the of 1/3. Well, we can modify that by putting the 1 up here and minus our denominator. But what did we say the log of 1 was? A 0. Remember, anything to the 1st power is 0. So 0 now minus what we have for a 3 up here is this. And our last one, E. All right, this one's a little tricky in that we have log base A of 2A. So that will give us then, as we tease it apart, log of base A of 2 plus log of base A of A. But what did we say A of A is? Well, that's a 1. And then our log of base A of 2, we said up here was this. So this plus the 1. This was the little tricky part. But again, have some of this in your notes so that you can use it if you have something like this again. And example F, log of base A to the 5th cannot be found using these properties because there's no way to make a 5 into a 2 plus anything. And the only values we have are a 2 and a 3 up there. Okay, a final property follows from the product rule. Since the log of base A of A to the k power is equal to k, we put the k out in front, log base A of A, and we have this now, and we just use this above, log of base A to the A is equal to 1. We have then the log of base A to the k power. Since this is 1, it's going to be a 1k. We don't write the 1. It's just going to be k. So here's a new logarithm of base to an exponent for any base A. We have log of base A to the k power is just going to equal k. Okay? Now for our last example. And if you know what we've just said, as we look at this is going to be a 7. And as we look at this, keeping in mind the rule we just had, it's going to be a negative 5.2. Now for any positive number, again, they give you a little rule here, a little summary of rules, where A does not equal 1. Here are some things you may want to include in your notes. I'm going to end the tape now because this is just going on 40 minutes, but pause it if you want to write some of this down or look it up in your textbook. And also keep in mind these are not true. Okay? Now, we'll go to our exercises. You'll do your problems, your examples, and then your quiz me, and good luck on it.